it start?
Just 10 seconds, another 10 seconds.
Yeah. Oh, it started, I guess, because I got a notification.
Yeah, it's getting started.
Okay.
Yes. Yeah, you can go ahead.
Okay. So good morning to all the participants, the audience, and the team mathematics at MS Ramaya. My first apologies to all of you for this unexpected delay. There was a delay from my side because my network, when I was talking about Murphy's Law to Professor Monica Anand the other day, saying that if things have to go wrong, it will go wrong no matter what it is. And it will go wrong at the right time. And that's exactly what has happened here. So I think some kind of prophecy I could make a couple of days back. So without any delay, let's get into this. My talk is titled Small Data, Tiny Clues, and Big Trends. You'll all be wondering as to why this talk, which is there in a workshop on big data. Why is this talk in a workshop on big data? So naturally, that makes it quite misfit talk or whatever here, and probably it's a misfit talk in the sense, when everybody talks about big data, mathematics, and all those stuff, and suddenly somebody comes and says, look, small data, tiny clues, then big trends, what is it all about? So let's see what this is in the next, let's say, 75 to 80 minutes of talk here. Okay. So the title of the talk is basically inspired or probably adopted from the book, Small Data, The Tiny Clues That Uncover Huge Trends by Martin Lindstrom. He's supposed to be a consultant in multiple companies who brought up companies from, dying down to profit-making companies. So the idea is basically, I thought it would be an apt title. So I thought I could adopt this. So with due respect and acknowledgements to Martin Lindstrom, I use this title. I acknowledge Martin Lindstrom again. So what is this talk all about? It's definitely not a math talk. It's definitely not a business talk either. So what is it going to be? Is it going to be storytelling or listening? Oh, well, it could be storytelling. It could be listening. We really do not know. But the next 90 minutes will definitely make it clear. Okay. So what is this huge buzz about this big data and stuff? So big data, machine learning, artificial intelligence, data science, these all seem to be the keywords or the buzzwords that people have been using, in the last decade at least, with the focus, you have on huge volumes of data, and you say that, look, I have petabytes of data, I have terabytes of data, I have whatnot. Now what I'm doing is I'm running some kind of machine learning algorithm to find out what meaning it makes. So you basically try to understand or gain some knowledge about the data that you have from the huge volumes of data. And the moment when you say huge volumes of data, the number seems mind-boggling, and our entire efforts go into probably working with the algorithm, or probably trying to fit some curve, or try to probably predict something, or try to make some classification, whatever that is. But then the problem is the amount of data is so huge that many times we really do not know what we're doing is right or wrong. So there is always a question of clarity. When it comes to a question of clarity, like, okay, this huge data, what sense does it make? Whatever that, my, let's say my algorithm gives me back, is that actually making sense to us? Like, what makes sense to me as a person working on this data? Maybe somebody else can come and contest that, saying, look, okay, anyway, whatever you have done has some kind of uncertainty, some kind of a probabilistic approach. Therefore, I would put something else and then question your probabilistic or statistical inference. Probably I would, I could probably give a completely different picture about it. So there is always this question about clarity as far as these huge volumes of data. And most of the times, it could also lead to a lot of confusion. It could do a lot of lead to a lot of confusion and probably chaos, in the sense that, okay, when you have volumes of data, you really do not know how to process this data. I mean, there's a lot of stuff that goes on. You say pre-processing, you try to remove noise, you try to do this, you try to do that. So there's a lot of interesting things that we do at the background, but still there's a lot of confusion that remains. I mean, though we say that, okay, we have done a lot of work, the again place the trust on the algorithm or the neural network engine or whatever. Now, I'm not trying to say that AI, ML, data science, data analysis, data analytics, everything is bad. What I'm trying to tell is, like, I mean, when you have a huge quantity, it is always a confusion. I mean, it goes from a simple example, right? Like, if you want to buy a mobile phone with a specification that you like, in general, you go to a mobile shop, you always feel that, okay, fine, is this model very good? Is that model very good? Oh, you have a lot of confusion when it's a problem of plenty, kind of, right? Uh, and the other interesting thing that comes with big data is basically consistency. Like, how consistent is your data? Like, are you, the data that you collect, is it all consistent? Are we making, are we reinventing the wheel, in the sense, like, you collect the same kind of data from same data, or probably the same kind of data from multiple people, and then try to, like, most of the times, like, what happens in our many of our exit polls during the elections, where people collect a lot of information and then still their prediction goes wrong. So there's a lot of stuff that happens, which is basically dealing with the consistency of the data that we already have. And relevance. I mean, these are some of the key words that you always associate with big data. The other things also being, data veracity, data validation, and even the data collection procedure itself is, like, many times questionable. So with all these things, yeah, of course, we have plenty of algorithms, we have plenty of tools which could analyze these huge data and probably give us some number or probably give us some insight. Ultimately, what we are trying to do is, when we do this analytics, we are trying to get some kind of insight about the underlying structure of the data. So when that happens, and you have all these kind of questionable things like clarity, confusion, consistency, and relevance, and of course the data collection methods itself, I mean, there is always a pinch of salt that you need to add when you take this data for its, I mean, instead of its true value. And of course, there are many of them which, we basically kind of, with what I could say, with big data, we're probably looking at some kind of a big picture, though there are many of really good researchers who end up getting into that pinpointing details of the data that you collect. Okay. Now let's look at this story of Lego blocks. I mean, the company which was making Lego blocks, where what could have actually gone wrong, especially with the notion of the analytics that they did with the kind of data that they had. So Lego, apparently in the year 2003, they had an $800 million debt. In the sense, they were one of the best toy making companies, and suddenly in 2003, you see that they have an $800 million debt. You'll be wondering, like, what's happening? This company which was making so much huge profits, and suddenly it's down. I mean, exactly similar to what we had with Nokia mobile phones. I mean, when the initial Nokia mobile phones came, maybe that 3315 or 3310 or 1100, all of us were very happy flaunting the mobile phones, in our hand. And in fact, many of these mobile phones were also brick heavy, that, when you hit someone, you're definitely going to hurt that fellow. And suddenly, with the kind of competition that, that came from Samsung and other places, you see Nokia is completely into oblivion. I mean, they're trying to make mobile phones now. I mean, mobile phones now, in the sense, trying to, compete with them. But then they were actually the true leaders connecting people 20 years back. And now probably everybody is back into Samsung and OnePlus and whatnot. So you have a lot of competitors who have come, and Nokia seems to be a bit lacking that punch in their, product or whatever. So it's like, who was once a king now kind of, gasping for breath, then it's a problem. So suppose in 2003, they had to really, they started making Lego, actually started making a lot of stuff other than the toys and the Lego blocks and stuff. You see that they ended up making a debt of this much magnitude. But in 2015, just in 12 years' time, they became the most powerful brand. I mean, what is it that happened to them? A time from nowhere, a time where they were actually, this is probably, what you call, life has lots of ups and downs. Like they were in the peak, then they actually fell down with this kind of a debt. And suddenly they became the world's most powerful brand. So what happened and what is the turnaround story? We'll probably look at it like a case study. But why did they even fall? That's a bigger question to ask. So these are the Lego blocks that you see. What is the turnaround story? Why did they even fall? Yeah, the fall is basically because, you had a lot of, they invested on a lot of other products and stuff. So naturally, they lost the focus on this Lego block, which was their core, their core product or something. So they really had an issue. And that's when the author of this book, Lindstorm, that I was saying, sought for advice. So they wanted him to develop some overall branding strategy for the company. Okay, so let's see what happened. So the reason is, as I said, what was the reason for their fall? Is basically they tried hands at many products that their core customers weren't interested in. So if you try to give something which your core customers are not interested in, then for sure you're in for a surprise. We all know this, there are many situations where which you would have actually seen. So people don't, for example, you look at this Apple company, you have core people who buy Apple 11, 12, whatever the generation that comes in terms of iPhone and stuff. It's not that they're going to stop buying. Of course, all the Mac products and stuff, they're not going to stop buying, but still they go, which means their customer base is always there, right? And if you try to do anything away from the customer base, then typically there is a problem, right? So let's look at that. So what did they find out? They had all the data from the time of inception till probably 2003-4. They had all the data they studied, and all the data, the big data analytics that they did pointed to only one thing. It just said future generations wouldn't be interested in Lego. That means kids wouldn't want to play this Lego blocks stuff at all. But in spite of that, now you see, you get into any of these malls or toy shops, you see such huge Lego blocks and things available right at the entrance to catch the attention of kids, right? So what was the reason that was given? After all this analytics was done, they figured out that, look, future generations of kids will not be interested in Lego. But then the justification was more interesting. It said the kids in this generation, they need instant gratification. And there's always a need for instant gratification. That is what was the conclusion. Okay, so it says need for instant gratification, more dominant over any building block would. So you do something, immediately you get a reward. So that's the kind of stuff that was pointing to. And they figured out that, okay, if this is what is going to happen, then we are in for a drown. That's all. So that's the story of Lego. So they felt that the fall was basically inevitable. Okay, so a company of that sort, if it is going to fall down. Oh, by the way, as I said, like, it's not a business talk. This is just a case study to point out, like, what is it that we have to do? Okay. When the fall is inevitable, you start looking at things differently. There is a need for us to develop a different strategy. And there is a need for us to even look at things in a different perspective, right? So what happened? So sometimes they wanted to really find out, they wanted to go to their core customers and then figure out what is it that they want in Lego. So in one of those visits, which they did in 2004 to the house of 11-year-old German kid, and they were on a mission to find out what made Lego stand out. So they were asking that kid, what is that and all. But what they figured out from the interaction with the kid was that everything that the data analytics that people did for the Lego building blocks, everything that has been told about the new generation kids, like instant gratification, they want a reward immediately, and all those things, they found that it was wrong. That is when they hit the customer base, they figured out that things were actually going wrong. Okay. Because on the other hand, the guy sitting there and then doing all kind of analytics and plotting algorithm and all those stuff, they came out and then said, look, this is what the kids are going to be. This is how the company is headed for its doomsday. But when they actually went to the real customers, then figure out what it is, they found whatever conclusions that they had drawn was completely wrong. The on the field, what would you call, opinion seems to be completely different from that of the fellows who are sitting there and then making all kind of predictions. So they basically figured out that there's a need for time compression. That means they want everything fast. So that was one of the conclusions that they had, and they found that this was wrong. And this instantaneous gratification, that was also something which they felt was actually wrong. So what is it? In fact, there was one question that they asked, which proved to be a very thought-provoking, which kind of pulverized the thoughts of these guys who went from Lego. The question to the kid that they asked was, what was his prized possession? So the kid ended up saying, look, it's a pair of beta Adidas sneakers with some bridges on one side and nooks on one side, which the kid said, look, I consider this as a trophy. But why would they want to look at such a kind of sneakers to be considered the trophy? These fellows trophy. So these fellows were like quite, what I would say is puzzled. Why would this even happen? Probably with the intention that, okay, with all these sneakers and stuff, he wanted to convey the world that the kid was one of the best in skateboarding. He was one of the best skateboarders in the city. So the Lego's learning is from the interaction with the kid seems to be just one point. One customer at one point that they figured out, despite having knowledge about the entire customer base or whatever that they had, they figured out something interesting. What they felt was wrong with the child was actually what do you call, as a misconceived perception that they had. But they figured out that any kid would try to attain social currency among their peers by playing and achieving high levels of mastery at their chosen skill. I'm quite sure most of us would also have seen such a thing happening in our own houses where you give video games to kids. It will not just say, I mean, it will keep playing and master at level after level, and then come back and tell us like, okay, I have completed this level, I have completed that level, and all those things. So there's also a level of mastery that they get by playing these, these games, and they want to sharpen their skills. Again, I tell you, this is not a management talk. This is going to talk about something insightful in a few minutes from now. So the finding was, if the skill is valuable and worthwhile, then they will stick with it no matter how long it takes. That's the most interesting thing about kids. That means they don't really care how long it takes, but then if they feel it is valuable and worthwhile, they will stick with it no matter how long it takes. Okay. So the Lego's decision till then was basically entire on the realms of big data that they had. But this German kid incident said that, look, a small chance insight made them refocus on core product, and they started building more number of blocks. They were focusing on more number of bricks and stuff, huge bricks and stuff. And so what it clearly says is, look, even though you have a lot of information that you have with you, it is always to look for certain insightful things there. Okay, that's why many of us, many people advise saying like, look, when you walk on a riverside, try to collect small pebbles around. What does it say? When you are embarking on an exploratory journey, try to look around and then gain more insights. Okay, so this, I mean, in the pursuit of a long journey, we typically forget the small picture that's happening around. So especially for a researcher, be it mathematics or be it engineering or or the latest AI ML, it is always required that uh, you make a lot of observations. You must have eyes and ears for small things. If not, I think we are in trouble. Okay. So what it says is, look, observation is the keyword. So for anybody, for that matter, observation is the keyword. I'm quite sure, uh, a great like Srinivasan Ramanujan, or probably anybody who worked on, let's say, numbers, or probably even astronomy in the very old days. I mean, they wouldn't have had the kind of machinery that we have, modern machinery that we have, which does the task. And therefore, all that they had to do was, they were trying to, get some data and try to work with that hand calculations they were actually making. So now we have all powerful tools, but then the idea seems to be these tools are more focused about the with the volumes of data that we have than the insights that we get with small piece of data. So the observation here is the key word. So typically what you do is, when you go around, it's always better to observe people and their cultures they inhabit from their own perspective. I'll give you an example which was told by one of these one of senior executives of a gold loan company. I'll give you in a minute. So when we do this, we actually have a lot of questions that dash our mind like waves, and say something like, how do groups of people form? What are their core beliefs? What do they aspire to, and why? And how do they create social ties? And do any of these local beliefs, habits, rituals, etc., have a universal significance? So these are, I mean, when we go to a different place, we really go take snaps and all those things and come off. But then the idea is to look around and see what is it that you can gain an insight from people around for that place. For example, this example of gold loans. See, there's a company in India that which I don't want to name the company, but they had been doing a lot of this business of giving loans for gold jewelry and stuff. But I mean, they were actually there were many people who were trying to pledge the gold on let's say Monday, and then trying to take it back on Friday, and then again pledge it on Monday, and then take it back on Friday. So this particular company was trying to figure out, what is this happening? Why would they put it on a Monday, Wednesday, or a Thursday? And why would they take it back on Friday? And why would they not do it on a Friday or a Tuesday? So they had a lot of questions, and they were trying to find out a pattern. And incidentally, they figured out that their demographic behavior, their religious behavior, or whatever, or their faith, or their behavior seems to dominate. I mean, there is a practice that people don't go pledge mortgage this gold or anything on a Tuesday or Friday, because they consider Tuesday, Friday to be very, very auspicious. And therefore, so they basically keep it in the banker's place, on a Monday, Wednesday, or Thursday, and then they take it back on one of these days, so that it doesn't hurt their religious feeling or whatever. So in fact, to this, when they looked at this kind of a behavior from a very small town, they figured out that, okay, they can fine tune their loan models and things. And that's how one of the most famous gold loan giving companies, they started building their brand as such. Okay, so basically what did they do? They were actually trying to look at people, look at their practices, look at their demography, look at their what do you call there's a lot of things that every individual contribute. See, every data that as an individual gives, to a to a particular say, for example, now we do look at Facebook, Instagram, and stuff, and we also try to purchase things on Amazon, Flipkart, and all those things. We always give our information that we give is what is helping them to build a kind of recommendation system which would suit only to us, right? So let us see what happens there. So the first thing that we would probably emphasize on is the fact that the observation is something which is very, very important. And that's exactly what our elders have also taught us, right? As I said, Srinivasan Ramanujan wouldn't have been able to write all the numbers that are there and then say, look, I have compiled the entire list of numbers of this, and then I went through one by one and then tried to get a property for this set of numbers. No, I don't think. For the simple reason that he was already in utter penury, and he had no other facility than to write on a slate and erase it off and things. So he would have worked only with a small, in what we call in modern terminology of machine learning, we say that he would have, or data analytics, we say that he would have worked only with small sample set of data. He would have worked only with small data, small sample. Based on that, now, what is the small sample trying to give insight of? Do we get any insight at all? And stuff. Okay, so this is what any of these what do you call mathematicians, famous mathematicians and scientists, in fact, they made all the discoveries based on small observations that they have made. Okay, so, and that's what we're going to call as small data. So the small data is something which is everywhere, which is omnipresent. Only thing is, we must, as I said, we must have eyes and ears for the small data. Of course, we know this. Anyone that uses smartphones create small data. What do we mean by that? Or when we log into any of these accounts, you actually tell them, you start liking the posts. You start liking, the posts of your friends and stuff. You start liking, certain influencers' Instagram posts. Say somebody posts there saying, this might be good. You go like, now, what do these fellows do? Facebook, Insta, and all. They try to rework, get your data, and then say, look, this is what this guy is looking for. So let's give some personalized ads. Many of us, we see that. In fact, Google also does that, right? Like we see a lot of advertisements, which is tuned towards our mindset. Facebook also, we see a lot of things which are tuned to our mindset. And in Amazon also, we see a lot of things which says like, people who bought this book, if you go and, try to purchase a book or a particular commodity on Amazon, it comes up saying, look, how does it know that somebody who got this product also bought something else? How do we know that? Basically, they look at the pattern and then they say, okay, you are trying to look at this book. I am able to get that you are looking at this book. Now I'll suggest that, okay, there's one more book that you can buy along with this. You are looking at this product. I'm going to give one more book or one more product along with this. That's exactly how you always see this. Oh, you have brought people who have brought this also. People who have bought this have also bought the other things, right? So it's basically giving you some kind of personalization stuff. How does it give? It's basically collecting some small information that you give. See, the information that an individual gives is basically a small data for companies. So the companies, what do? If they try to focus on this data that you give, and then try to do a lot of personalization, and that's where the cost is. Okay. So you click an ad, or probably you search for a product which you saw on some influencers, Instagram or Twitter accounts. I mean, most of the times you see these movie fraternity fellows go and show they endorse for certain products. And then what do we do immediately? Okay, fine, let's go and check this. We don't even care what it is. We'll go and check. I mean, a typical example is like if somebody says, buy this soap, I'll give you 10 rupees pen free. I mean, we flock basically because it is endorsed by somebody else. We say that, okay, fine. If I get the soap, I get a 10 rupees pen free. I mean, instead, we could actually go and buy that 10 rupees pen separately, right? We would be paying for the soap and then we'll also be paying for that. So there's a lot of things that people do based on the data that we give, right? And it is not that, I mean, sometimes it's also a collective data that people collect and then look at it, but it's also many times that individual data that is given and accordingly things are tuned, okay? So this is what matters. It says insights and observations plus small data will be the foundation for future brand or any business that people try to do, especially from this domain, like whatever ML deep learning that people do now. The focus is going to be more on, all these small data that we get, and based on the knowledge that we already have from whatever we have collected. Okay, so for example, let's look at this. This is basically the first generation of your touchscreen phones. The top one is basically the Samsung ones, and then of course we see this Apple iPhone, which was announced and released on 14 years back in 2007, which had all these features. And now where we have gone, right? We have gone leaps and bounds in iPhones, but we have those faithful customers who still go and buy iPhones, irrespective of what the cost is. You're not going to have an Apple user to ditch Apple and go at any point of time. Now, can somebody understand what is the effect of using all these touch phones and stuff? Prior to this, we had this Nokia 1100, as I said, 3310 phone, where you need to really press the keys and stuff. In many cases, you also have to probably slide and position your alphabets and stuff, rotary motion kind of things we had. But after that, we had mobile phones where you had to press the key. Right, you had a keypad where you had to press the key physically and then do it. But then with the kind of touch phones, when we started getting the touch phones, what is it that we found? We found that we don't have to put more pressure on the keys to press the alphabet that you want or do anything on the phone. So what are the kind of consequences that we landed in? So in fact, if you look at the first generation of smartphones, or probably even the smartphones that come now, the way the smartphones have taken different avatars these days, one cannot really imagine who's at the, who the set of people who've been, in their middle age at that time when the first generation of smart mobile phones came. And of course, they still continue to be in the dark, because now you see that the way, the pace at which the mobile phones, the smart touch phone mobile phones have grown is like enormous, that people are still not able to keep up with the pace at which they've grown, especially the old people. They still figure it out. There are many people who still find it difficult. They're kind of, many of us we see in India that a 2-year-old kid or a 3-year-old kid operates a mobile phone much at ease than anybody who's at 60, 65 years old. This is always the case. So what was the consequence of this? So they found that kids to be adapting for the smartphones very easily. Now, in fact, what is interesting is, this is something which people can do, or probably people have also done. It says, if you study the number of smudge marks on a phone or a tablet screen, you can easily determine the age of the owner. This is some small data, again, that we leave on the mobile phone for people to look at, which might not be of any interest to the kind of research work that we do. But you see, it still gives some kind of hold for you to make an exploratory journey. It's like, how many would have even thought of this? It's like, I'm giving the phone to you use the phone, so it should be yours. So suppose if the phone is lost and if somebody is trying to do some kind of fingerprint analysis and all those things, the moment they find all this kind of things, there is always a mechanism to find out what could be the age group of this owner, right? That's a very interesting search. It's on a single phone, right? It's a data that is given by a single user who will be using that phone. So it kind of gives you an insight into the age of the phone. Okay. So what is interesting is to look at the side effects. The side effects of using these phones. It says the evolution of the smartphones is this. It started from knobs to keys to touchscreen smartphones like what we have. But what are the effects? we already know that the ability to write is gone, right? I'm quite sure many of us who use this smartphones, we don't even, I mean, many of the kids that use, they find it very difficult to hold a pen and write it on the, notebook or whatever. And many a times, the language skills are gone, because why? When we have a smartphone with a touchscreen like what we have now, we really don't care what we message. Instead, we just swipe it and go off. I mean, I had a very interesting incident with this, as far as this language skills gone. Like when I was teaching a course in Suratkal, there was a company which had come for campus interview, and because of the interview process, I thought I'll reschedule my classes. Then one of my student came back and said, "Sir, you don't reschedule your classes because." Uh, uh, I mean, I said, he said, don't do it, because the ones who want to attend the interview will anyway be going. All of us are there. You can. Then I said, okay, look, why would you want that? Let me take that class for everybody. Then another friend of him, he said, look, sir, what your decision is fine, because many of the students, he messages me on, WhatsApp saying, many of our students don't want to kiss your class. Then I wrote back to him saying, look, dude, that's not kiss your class, it's miss your class. Did you swipe your phone? Right? So the language skills is gone. Once you swipe and send, it's all gone. Like, you don't really care what is the message that you're sending, or what it is. So you've lost a lot of things there, right? I'm sure most of us also have this habit of giving a support below the phone when we hold the phone. It's not that you hold it by side. There are many of us who hold the phone with our pinky fingers down, and when you hold down, and then these kids, when they keep talking, for over hours, you end up seeing them develop indentation on their pinky fingers. Therefore, the hands become weak, which you could actually see when you try to shake hands with the kids of this generation. You see, the grip of the kids which give us the handshake. It is very, very weaker one that you see. So that you get weaker grips. What is the consequence of this? That's where this small data things, looking at things in a different way, comes into picture. What was the consequence of this? Did anybody study this? Yes, of course. The effects of weaker grips was capitalized by what we call as fast moving consumer goods, people who are selling cool drinks and stuff. The way they have the bottle lids that they develop, they have started making it such that it is meant for people with weaker grips. I'm quite sure most of us would have used syrup bottles in our life. At one point of time, most of us would have actually used a knife to cut. It used to be so tight that we used to use a knife to cut where it joins the lid and the bottle. We used to cut it using knife and all. Now what you need to do is we just need to, unscrew it. We can unscrew them very easily. And in fact, car keys have become, for all this soft fingers type. Car keys have also been started manufacturing. I mean, people have started manufacturing car keys also in a manner wherein which, it is useful for all these guys with weaker grips. So you see that when people try to focus on something big, there are some people who are looking at, these interesting small facts that go around, which could actually turn out to be a big trendsetter. That's exactly what the title of the talk was. Just small data, tiny clues. These are very, very small clues. Nobody, I mean, if it were given to any of the researchers, they wouldn't have even looked at it. But for corporates, these data are the ones which is going to make a huge difference, right? So you see that the effect of weaker grips can be immediately when they figured out that things are going wrong, these guys ended up saying, okay, we'll make bottle lids of this sort. We'll make car keys with of this sort, right? Okay. Oh, this is another inspiring story. See, this is a time when, our people went and stood in queues to, buy and keep things in stock at home, because they were anticipating lockdown at, at any point of time. So every time when you have a lockdown, people feel that, okay, fine, I should go. Many of us even do panic buying. And then what happens? You see that when you go to big shopping malls, when you go to hypermarts and places like Spar or any other place, you find that there's a huge queue. Everybody would have bought things, but then there's a huge queue at the counter. Now, if for this huge queue, if you stand, whether you wear mask or not, you would anyway you will anyway have your consequences, because you don't even know what's the kind of people who are coming. It's so many people stuffed inside a small area. You wait for that queue to get over. By the time the queue, you move to your paying, bill paying time. I mean, that guy will sitting there will say, no, I'm off for lunch. Please wait for 5 minutes. I'll come back. That's the most frustrating thing that one can ever think of. But, there was a very interesting company, which there were a few guys who, engineering college graduates who are looking at this. You go there, you see that, okay, in the hypermart, there is a problem with this billing system, because you have to buy things and you have to wait for the queue to pay your wait in the queue for paying the bill. Why not we start an why not we start an application out of this? That's how this company called Purple Pay, it came into existence. They were watching these fellows standing in queue, and then figured out that, okay, fine, let me do a product, or probably an interface, or probably an app, which will help people scan the things that they buy, and then make a payment through one of these payment interfaces that they have. Like they try to interface it with Paytm and Google Pay and stuff. So you say that, okay, I'll scan all these products, I'll get the entire bill, I'll pay it through the Paytm app or any of these pay apps like Google Pay and stuff, and then I check out. I don't have to wait in queue. This company was called Purple Pay, which was probably started in the year 2017. One of them happened to be the co-founder was my student from Surathkal. And what was interesting is 2017 they started, and then 2021 Amazon acquired them. That's the biggest thing. See, it's not that somebody has to go around shopping malls everywhere or look at queues everywhere and then wait and then say, look, there is a lot of queue that is happening, and therefore I have to do this. See, one place, one idea, immediately start, and within 4 years it got sold. So what we look at is, as far as data science is concerned, data analytics is also concerned. It's not about, and of course, building brands, or probably even trying to start up something on your own. You don't really have to wait for a lot of observation, and then especially when it comes to a software app like this. Of course, there should be a lot of brainstorming that happens, but typically what people do is you get an idea, you just don't wait for you don't wait for the day to dawn and then say, okay, fine, I'll do this. You start off immediately, try to keep keep updating, and all these things are based on small observations, small data set. You don't really require 1 million data points to say that, okay, people across 1 million shops are like, across shops are like waiting and all those things. It's just one shop, some 2 hours of waiting time. You see how the customer's billing is done. You are already at it. So these small things make a lot of difference. That's exactly what I've been saying. Small data definitely makes a lot of sense. In fact, because we already have a knowledge from the data that we have already acquired, but these are small. We could not even call it as outliers, for that matter. We cannot even call them as outliers. But these are actually interesting stuff. Even in numbers, when you work with math, it's always nice to look at patterns and stuff, right? It's always nice to look at patterns and then start working on things. That's exactly what I was saying, right? Even in the beginning, like Ramanujan would have seen a pattern with very small amount of data and said, look, now I'm going to do this. Yeah, but then there is always a caution that we need to exercise. What is that? The caution is like, not at all times the data that we get, especially when it is in small volume, could actually make sense, because it could always be noise also. And it could also be something junk, right? So what it says is small data done well provides the insights and clarity needed that are almost impossible to find with volumes of data. That's exactly the point that we need to look at. When everybody is like, thumping their chest with saying, look, big data analytics, big data science, and huge volumes of data and all those things. The small data always provides a lot of insights, and it also provides clarity. I remember Professor Vittal Rao's words from in the Indian Institute of Science. He always used to say, look, when there is something complex that works, it works only because there is something very simple underlying it. Try to look at that. If then everything is fine. So that's exactly what it says. See, when you always have, when you have a liking for something big, you must also start looking at small things around. That's what I said. Like when you go on a riverside, collect all the pebbles that you get. It's not that I'm going to focus only on this and then I'm going to do. It's not a highway ride that you need to do. You have to really enjoy your journey, which means these enjoying journey are looking at small insights that you get. These could be, moments of epiphany and stuff. Okay. This is the most interesting thing about small data. It says, look, it delivers insights where big data is overwhelming. Right? Big data could be really overwhelming. Like we won't even be able to do anything with that. But a small data set could definitely give you more insights, provided it's a valid one. Let's look at what it is. Oh, but Prof, what is the question? Small data. You haven't even told what is it. We've been talking about big data. We've been talking about something small data and all those things. But what is even small data? So the data that humans can observe and process personally is what we call the small data. Info about any individual in a crowd is small data. Any individual. That's the key point here. Any historical use of small data? Of course, these guys have done it. I'm quite sure they wouldn't have really had huge volumes of data to, make sense out of it. Ramanujan, be it Srinivasan Ramanujan or be it Charles Darwin, they would have all worked with. I'm quite sure even in the first day of the workshop when Professor Ashok Rao was talking about big data, how to measure the Ptolemy's well experiment, he would have explained, right? So we see that the physicists actually made calculations by hand. They were not looking at powerful computers or whatever to give whatever discoveries that they made. They were looking at nature. They were trying to, model nature. They were trying to study a lot of things about nature. But then all that they had was they could only observe. We did not have the sophisticated. I don't even know if you could call it the so-called the sophisticated ones, because what they were doing with natural intellect at that point in time, we are not able to do it now. All right. So the physicists actually made a lot of calculations by hand and discovered some of the most beautiful and fundamental laws of nature. They were not going behind systems, or they were not going behind computers or whatever, which were even non-existing at that time, to come up with their discoveries. So data is something where a statistician can sit and work out and then find out what kind of information that it reveals. Okay. So where do you use small data? It says like when you make a solution for an enterprise of limited numbers. We must know that a single shoe doesn't fit everybody, right? Typically, what happens is like, this is everybody knows. That means a single decision cannot fit for everybody. It is going to have all kind of grumblings, right? Then time series. This is even more interesting. See, understanding that time is short in supply is more important. Many of us, I don't know if we actually value time, because all of us would have faced this at some point of time when we really want to meet all our friends. We say that, okay, let's all meet at 4. And then you'll always have a friend who even at 6 o'clock when you call will say, look, I'm on my way. You don't have actually even started from his house. And these are people who don't respect time, right? So time is short in supply is more important understanding that we always take. However, users, queries, documents, there's absolutely no shortage. You have huge volumes, right? Suppose if the ground truth is going to be a daily number or 1 point in a day, we cannot wait for, you cannot really wait for 10,000 days to collect 10,000 samples and say, look, now I'm going to work on it. Is that right? It's going to be a huge thing for us. We're just going to get one data point a day. for me to get 10,000 data or probably 1 lakh data points, then I'm really going to be waiting for those many days, right? It's going to be pretty difficult, right? So in that case, what is it that we do? We cannot really wait for that huge volume of data to be collected and then start working on it. And the other thing is like when you want to model a rare phenomenon, say for example, earthquakes, tsunamis, right? These are once in a time phenomena, are very, very rare occurrence ones. And again, you cannot wait for gaining a lot of info, right? And it's also used where aggregate modeling, where the population is limited or sampling is really expensive. When your sampling process, the population is limited and the sampling is going to be extremely expensive, then there's no point in working for what we so-called big data. So it's the small data which makes a lot of sense there. Okay. The data is like it's not just small. Let's look at what is known as wide data. Let's see what is that. So basically, when we try to solve problems which deal with increasingly complex questions on artificial intelligence and very scarce data use cases, we don't want the same kind of data to be available, but we want a variety. And that variety is what we call as wide data. So we're going to have wide data, which is nothing but small in quantity, but then it's a wide variety one. Okay. So this enables the analysis and synergy of a small variety of small and varied, most important thing, unstructured and structured data sources. It kind of enhances the contextual awareness and decision making, right? So then you have to look at see that I'm quite sure this would also be a question which Dr. Ashok would have asked. Do you want 260 samples of a single alphabet when you want to recognize alphabets, or do you want 10 samples of 26 alphabets to distinguish? I'm quite sure we would want the later one. I have English alphabets from A to Z. I need at least 10 different ways in which people can write the alphabets of each of the alphabet, which would help me in recognizing these characters when people write, rather than having 260 samples of a single alphabet. Now, what is the purpose it's going to solve? It's going to solve nothing. But if I have, a wide data, right, that makes more sense. But then smaller samples of wider data would make a great sense. That's what it says. Enables the analysis and synergy of a variety of small and varied, unstructured and structured data sources to enhance contextual awareness and decisions. So in most of the cases, when you collect the data, therefore, the data collection becomes very, very important, right? Like when we say that we are going to collect data samples and all those things, there is always some noise that is there, and there may always be some kind of redundant information which may be there. There may always be some kind of this noise is what we try to call as irrelevant fellows or whatever that is there, right? So if we are able to, let's say you want to make a survey on the academic system in the country, it is better to ask wiser questions than putting a lot of questions and then try to get some irrelevant answers, which does not even make sense. Even if you get from across all the students in the country, it is not going to make sense. So the thing is, what we must do is we must ask the right questions. Okay. While the wide data is going to give you, a lot of information with small set of samples, small data is going to give you a lot of insights, right? So you have to couple your knowledge that you've obtained with big data with that of your smaller wide data. Let's look at this. So it says important conclusions you can draw only from small data. As I said, the gold loan giving company in the country was actually looking at a small population which was trying to pledge gold on a particular day and then taking it back on another day. So you have a lot of things. In fact, okay, let's look at this. So it says insight into individuals' personality, habits, motive, etc. can be studied only with small data. Why is this important? I'll come to it. I'll come to it in a minute. It can be packed with meaning derived from personal data. So that is more, that's the thing that you're looking for. But what we actually understand is the massive data that you have, it will always obscure this meaning, right? It will always obscure this meaning. Simple thing is like when you have ML, when you do, okay, I have heights and weights of some 200, 300 different people. I want to study some kind of a correlation. What is it that we do? We try to say that, okay, I have taken these many samples, the data lies in this many dimensions, and but the structure actually lies in a lower dimension. This is what you say, no? The curse of dimensionality. We always say that the curse of dimensionality, principal component analysis, all these things we do. We typically look at huge volumes, and then what do we say? We try to get that information which is available at a lower dimension, right? Your PCA is all about projecting data in a higher dimension to a lower dimension, and then trying to learn, right? Okay. What is interesting is when you work on massive data with all our machine learning algorithms, what we want is we want to figure out a meaning from we want to derive information or insight to individual's personality. But all our machine learning methods that we have, since it is going to be from across many individuals, the machine learning methods is going to average out the meaning. That's exactly what that recommender system that I said. See, what it does, it basically looks at the products that multiple guys purchase. They also see along with this product what is being purchased, and therefore it comes back and says, look, those fellows, many people have purchased this, and then they've also, along with that, they've also purchased this. So we suggest you also do this. This is the kind of recommendation that we get. But that is basically an information that we get as an average meaning from across people. So that's another problem that we face. Okay. So the machine learning techniques that we have basically average out the meaning. That is not what we want. If you look at artificial intelligence, I'm quite sure most of us are, familiar with this meme. It keeps coming in your Facebook. You go into any Twitter page, you end up getting this meme. Instagram also, you see this meme, and most of the times, even professors are made meme materials with this kind of thing, right? So if you look at it, artificial intelligence is actually not about data processing. One thing we must understand: no AI ML method is about processing the data. It is more about mastering the knowledge. That means what is that information that you get out of the volumes of data that you have, right? So that is what your artificial intelligence is all about. Okay. So don't say it is data processing, say it as mastering knowledge. That gives another edge for you, right? So where is this small data useful? The most important place where people have found it to be very, advantageous is especially the fashion industry. Now you design a shirt on your own. You don't have to go buy and things. Now you have a wide variety of options that you have of colors. You try to put whatever design that you want. That's a blank T-shirt that you see on the right-hand side. Then you can see what are the kinds of designs that you can put. Then what are the colors that you have. You have a color matrix out there. So this is basically going to, it's an exploit of the small data. Is that clear? That means it allows personalization for individuals, right? That means, it's a very personalized experience that we get, right? So basically, small data helps you move from average-based analytics to immediate decision making. So what we do here, okay, you put one color, this color, and whatever multiple colors that you want to put, and then say this kind of design. Then we know whether we like it or not. Immediately you make a decision and then say, look, let's go ahead. Let's do another design. So it helps you, this kind of apps help you build your own design, customize it for your own need, and then purchase, right? There are many online sites which allow you this kind of a personalization, right? So that's what it says. Move from average-based analytics to immediate decision making. From multicast to individualization, that's what it says. Multicast is basically this kind of averaging out stuff, and then to individualization. generalization to personalization. So these are the advantages that we get with small data. Well, that's that kid which says, look, now I know the purpose. I've got it, right? This is another things. Interesting that you see. It's basically a video. You could probably look at video. Just give me a minute. Just a minute. I'll show you that video. Is the screen visible? Hello?
Yes, sir.
That video is visible?
Video is not visible.
Hello?
Video is not
Video
visible.
is not
sir.
visible,
sir.
fine.
It's visible,
Video.
Video feed is coming
but video is not
from
playing.
YouTube. Okay,
You
fine.
can
That's okay.
See
Anyway,
the
let's
picture
just check
of the
this.
shoes.
Okay, fine. Yeah, sure. So this is basically somebody who wants to buy shoes, right? Now what we do, we go and check in any of these footwear shop, and then we wear it, and then we see what is the kind of experience and stuff. Instead, they have an app in Japan. If you see, they have an app wherein which you give your features of your feet. You say that, okay, this is the size that I have, this is the width of my feet I have, this is the kind of toes I have, width I have there, the tapering that I have, then this is the model, the shoes that I'm going to give all my data pertaining to my feet, and then I'm going to get a shoe corresponding to that, which shows all the kind of dimension. Unfortunately, since I made it as a PDF, I'm not in a position to show that video. Let me just check if I can still play the video. Is just 1 minute. Is this video on? Can you see the video?
No, sir.
No. Okay, fine.
No.
Let me just check. I will probably. I'll copy the link and probably put it. Oh, I can do it on Zoom. Let me just check if it works.
Okay.
Oh, okay. I'll put the link there on the chat box. People can actually check it. Just give me a minute.
Yeah.
Yeah. Probably the host can play this video for a minute.
Yes, sir.
Anybody? Yeah, Sushma, can you play that video?
Yes, sir.
You
Yes.
can. Oh, but it will stop my sharing, right? Oh, I'll finish the entire stuff and then we will go ahead playing that video. Okay.
Okay.
Hello. Yeah, I'll
Yes,
finish
sir.
the entire stuff
Yes,
and
sir.
then we'll go. Yeah.
Yes, sir.
So yeah, look at this. So this is the kind of information that we give individuals information, and it also helps us get the most personalized stuff. Okay. Oh, it has come in terms of okay. So, but what are all the issues with small data? See that we could always overfit. Overfitting is a big problem. Training data and validation data, it's always overfit. And you see that machine learning is basically a luxury. So what you do, just hire a statistician or probably have a subject expert who could be, giving their opinion on things. And when you have a very small amount of data, the problem is that outliers could be very, very dangerous. And in fact, the data that you've collected could entirely be noise. So you cannot rule out that, okay? One more thing that we need to do is like, small data is human-centric. So that is something which we need to understand, okay? So the question is, can we make machines which can, that can from small data, that can learn from small data? Can we have all this deep learning that we have, which works on huge volumes of data? Can we make deep learning which learns from small number of data points? Is it possible to do? Right? In spite of, okay, how you have developed some deep learning algorithm which could actually learn from smaller data points. But the question is, can they extract the necessary information or non-linearities which are there present in it? Can they learn like human being and then do it? That's a challenge that we need to look at. So the crux of the matter is Like when everybody talks about big data could definitely be overwhelming. So it's always to look for smaller, what you call a small wide data, which can give a lot of insights. Okay. So the benefits, it says it is an immediate translation of data to business intelligence. Individual is on board. The customer satisfaction, which people keep talking about, is very much there, because the customer is taken along with whenever you have, I mean, in this kind of an analysis, the focus is on the end user. So, I mean, it is like, there was a time when people were talking about oversampling and all those things in terms of signal processing and stuff. And suddenly somebody comes and says, look, we can even work with undersampled data. Then somebody was talking about volumes of data, and somebody come and said, look, we can look at things in compressed domain sensing and a lot of stuff. So now when people talk about big data, now there is a focus. It says, look, no, let's try to work with small yet wide variety of data, which could throw more insights than what we would get with volumes of data. Because small data is simple data. So with that, I would probably end my talk. I think I would request the organizers to probably play that video that I had sent. But before I wind up, I would like to acknowledge all the bloggers, corporate websites, and authors of various books, and every individual which has helped me make this material. So I've not individually cited the references here. I'm making it as a complete acknowledgement to all the people, because again, it was not from one side. I must say the talk was opposite to that of what I did. I was collecting information from many sites to talk about what we call a small data. Basically, I was looking for the variety. Okay, so I would like to acknowledge all the bloggers, authors, and corporate websites, and every other individual and material which helped make this material. And I thank the team of Ramaya and the participants for inviting me for this. And one more thing is, I apologize profusely for the delay in start today. It was more because of my internet issues, and I had some trouble with my Zoom. I just hope in future things don't happen this way. Thank you. Thanks all. Are there any questions or comments?
Yes, sir.
Can I stop sharing so that you can play the video? We'll see the video first and then go
Yes,
for
sir.
questions. Yeah, I'll stop.
After video playing, we will ask the questions.
Sure. Yeah, sure. Yeah, you can play the video now.
Can you see, sir? Can you see the video?
Yeah, I can make it full screen.
Yeah.
Make it full screen.
Yes, sir.
Now play it again. With the audio, you can play. It's not this Zozomat. Go back. This is an advertisement, I guess. Not this. Is this the link that I had sent? Is this the link that I had sent?
Yes. One second.
No. This is virtual show fitting.
This is the link with this link only we open, sir.
Okay. Does it say virtual shoe fitting? Yeah, exactly. Now you play this with the audio.
Oh.
Yeah.
Yeah.
Is it over? Like, can you play it again? Sorry. That's what it says. No, it's okay. Leave it like that. It says, scan your this one, scale the foot symbol. Now you do try on. So it gives you all the dimensions of the shoes and stuff. You want to buy the shoes. So which means it gives you a complete experience about what it would be for a particular shoe. That's what it says. So they've actually developed an app. In fact, this could go a long way for individual special kids which require individual attention. It could also help. Such technology could help individual kids learn much better. So you see here this. Yeah. So you scan the app, show the take the with this one you scan your feet. So you get a complete picture of like what happens when you try to. This is the kind of experience that we get when we try to personalize this. Yeah. I think we can stop the video. Yeah. If there are questions, I'm ready to take them.
Okay, sir.
Yeah. Are there any questions?
Yes, sir. A couple of questions from participant side, sir.
Yeah, please.
First question is, does the Lego case study mean that the data was analyzed in a wrong way or the inference drawn was wrong?
Oh, that's a very interesting thing. In the sense, you cannot see they were looking for something. Your data will point to what you are looking for. That is something which we must understand. Your data will give what you exactly want out of it, right? But in most of the cases, what we want is we want to have a different thinking. We need to don a different thinking hat such that we also start, getting a taste or a flavor for the information which is not revealed in it. Say, for example, if you want to conduct an exam wherein which the students have to fail, you will end up conducting an exam where the student fails, no matter what it is, or no matter how much a student has prepared very well, right? So you cannot say the conclusion was wrong or did they actually miss out something. The point is like they were trying to look at it from a single perspective. Therefore, that's exactly why I said you must always have open ears and eyes for new thoughts and new interpretations, right? Typically, this is also told in all kind of PhD things. So whenever you start doing your PhD research, we always say this, you start with something, do something else, then you get your results. When you get your results, you go back and say, this is what I was looking for. Right? Most of the times that's what happens with our PhD research also, right? So start looking for something, get results for something else, go back and say, look, this is what I was. So we must be in a position to, we must be in a position to accept new kind of ideas and thought processes. Directly, you cannot brand them. For them, at that particular point of time, the analysis that they did, what kind of interpretation they got, it was correct because they were looking for something of that sort. They were trying to find out what is the problem. They found out that this was the problem and this was not. But it required somebody else to go back and say, look, it is not the problem because the core that you have is not going to change their attitude towards you. Best example is Apple iPhones, right? How much ever costly it is, people can pay 60,000-70,000 rupees or even 1 lakh to buy an iPhone. I mean, they're not going to stop from buying even if the iPhone cost goes high, right? Yeah.
Thank you, sir.
I hope
One
that
more.
answers the question. If there is any other comment on that question, you can tell me. I hope that answered the question.
No, sir. No comment, sir. One more question we have, sir.
Hmm.
Can the machines learn from big data and use it to interpret small data?
This
Shall I repeat?
well, it is true. It is true in the sense, learn from big data and then interpret it to small data. Well, I mean, you can do it, but then the kind of insights that we have, this is something on the lateral thinking side or whatever that you can call. This is something different. See, we always do this, right? In ML, you take a larger number of training set and then you try to test your algorithm with whatever the test data that you have. You are going to train and then basically going to test on whatever the test data set that you have, right? So you are learning from the training data set and then you are trying to find out, or you're going to apply that to your testing data set and check whether the data that you got for testing, it has the same features that you would have actually extracted from your training data set. Okay, but these questions, as I said, this small data, whatever that we said, these are typically things which only human brains are capable of handling. Human mind is capable of handling because we always have that what you call extra liking for some more details, which a machine which an ML algorithm cannot do, because you have actually programmed your ML algorithm to be that way, right? That is why the question I ended the entire talk with a question that says, can we have deep learning algorithms which can actually work with very small amount of data and yet provide all the information that we have, right?
Thank you, sir. Thank you for giving wonderful talk on small data, tiny clues, and big trends. Thank you, sir. On behalf of the Department of Mathematics, I would like to thank once again, sir.
Thanks a lot. Thanks a lot. Thanks to the entire team, and thanks to the audience for bearing with me for this much time. Thanks a lot.
Thank you, sir. Dear participants, we will meet at 2 o'clock for the next session. Thank you.